So hey everyone, today we'll be discussing the next question of DP sheet, which is distance sequence. So let's see what the problem statement says. So yeah, we have to find out how many sequences, say A of the order say A1, A2 up till AN of length n satisfy the two conditions. The two conditions are, say we have the sequence A2, A1, A2, A3 and so on till AN. First condition is that AI should be less than equal to M and greater than equal to 1. And the second condition says that AI minus AI plus 1. The absolute difference of AI minus AI plus 1 should be greater than equals k, which simply means that the absolute difference between any two consecutive elements should be greater than equal to k. The question is quite straightforward, and so yeah, let's look at the constraints to like analyze and make some observations. So n is say till 1000 and m is say till 5000, right? So a DP state or of say order of 5 into 10 to the power 6 might work, right? Because that definitely comes within the time complexity of the problem. Now coming to why it's even a DP problem, right? So say we are building up the sequence and we are at say I and we have fixed some integer x. Then we for the next position we need to check, right, from for all integers from 1 to m which all numbers can be placed here, right? Can we place a 1 here, can we place a 2 here and so on, right? So we definitely need to try all possible cases. So therefore a sort of a recursive or a DP approach comes to our mind. Now let's see what can be the DP approach and why DP even, like how we'll see how we encounter some overlapping sub problems and stuff. So yeah, interestingly, it's the DP state may seem quite straightforward to you. It simply say we define DP of I comma j as count of I length sequences such that last element is j, right? So that's a pretty straightforward DP state. And if we think on the lines of this DP state, then what could be the transitions, right? So we are at I sequence A, and yeah, and this is the first position, this is the I minus 1, and this is the ith position, right? So say we have fixed the element j here, and we are currently at the state dp of I comma j. How might we have arrived at this state, right? That's the question to ask. And we can simply check for these previous position x. Say we put it x here, right? So we can just check x from 1 to m and we try to put each element here and just check ki if x minus j mod is greater than equal to k, right? And if it is, we can put the element here, otherwise not, right? So simply we can say that dp of I comma j can be the summation of dp of I minus 1, the previous state, and x. X can grow from say 1 to m, right? And that's precisely the DP transitions. And the only constraint is here that this is only true if x minus j mod is greater than equal to k, right? And that's a very simple DP state. And let's iterate again on the solution. So here I'm at the ith index. This is the I minus 1 position. And say I've fixed a j here, right? So we can just check, can I put a 1 here? When can I put a 1 here? If 1 minus j's mod is greater than equals k, right? And can I put a 2 here and so on. I can just run a loop from 1 to m and check if can I put the element here. If I can, then this simply means that from this state I can go this state, right? So just I add that state dp of I comma j, I add it to this, right? I minus 1 comma x, right? If x minus j's absolute difference is greater than equal to k. So that's precisely our DP transitions. Now on lines of this, what will be our final answer, right? what could be a final answer? So in the end, we want the n length sequence. So something like dp of n comma x, and say this is the sequence, right? What can we have a 1 at the last position? Yes, we can. Can we have a 2? Yes, we can. Can we have a 3? Yes, we can. So final answer is just summation x from 1 to m dp of n comma x. That simply means dp of n comma x is the count of a n length sequence. How many n length sequences are there with the last element equals x, right? Last element can be a 1, last element can be a 2, last element can be a 3, and so on. Last element can be a m, right? So that's it for the final answer. And the base case is also quite simple. So the base case is, say I'm at the first position, right? Can I have a 1 year? Yes. How many? Say I'm defining dp of 1 comma 1. This simply means how many one length sequence are there with the last element equals 1. This is 1 only, right? And on a more general note, we just have a one length sequence, say a1, right? A1 can be any number from 1 to m, right? So simply dp of 1 comma 1 equals 1, and so on till dp of 1 comma m equals 1, right? Because how many, this simply means that how many one length sequences are there with the first element equals, first and only element equals m. It's simply one only, right? There is a single sequence, and that is m, right? So that was it. And you might be wondering that this might give us a TLE, and you are right, and we'll see how we can optimize this further. So yeah, first let's look at the code. Okay, so yeah, we have a code here. So I've just defined a mod as we need, the count can be a very large number, so we need to take modulo this number, right? Okay. Now we had discussed, I just taken the input nmk, and we had discussed the base case, right? Simply dp of 1 comma j equals 1, right? And j goes from 1 to m. I'm now coming to the transitions. So yeah, this is quite simple. I from 2 to n, because we have already computed for I equals 1, and we just check for each element, say j. So j being the last element of the sequence, right? So say the ith element is j, right? So we are computing dp of I comma j. Now say this is the ith sequence, right? What can be here? Say x, right? So we can just allow loop through the previous element, right? The I minus 1th element, and just check if absolute of x minus j greater than or equal to k. That's the condition given in the question. If it is, then that simply means that we can grow from dp of I minus 1 comma x to dp of I comma j, right? And so that's it. I'm initializing a temporary variable temp and just adding all the values and taking mod. And in the end, I just assign dp of I comma j as temp, right? And the final answer is also simple. We just have discussed that. It's just that the last element of the sequence can be any number from 1 to m, right? And that's precisely what I'm doing. So answer is just the summation of dp of n comma j, where j goes from 1 to m, right? And I just take a modulo and output this. So the crucial thing you might have observed, right? There are just 3 loops. So the dp state is order of O of n into m, and the transitions are order of O of m, right? So the final time complexity is order of O of n into m square, and that definitely will give us a TLE, just because n is anyways 1000 and m is 5000, right? So this becomes like 10 raised to 3 into 25 into 10 raised to power 6. So it's greater than 109, so it will definitely give us a TLE. So we need to optimize this further, and let's see how can we optimize this. Okay, so one thing to note here is, say I am computing the answer for dp of I comma j, right? So say the ith element is fixed to j, right? What can be the previous element from which we had reached to this state, right? X can be any integer from 1 to j minus k and j plus k to m. I hope this is clear, because can we have a 1 year? Yes. can we have an integer j minus k here? Then the absolute difference just becomes j minus k minus j, which is k, right? Modulo of minus k, which is k. So a max element smaller than this, that it can be j minus k to have an absolute difference of k, right? Similarly, of picking elements greater than j, we can have any number from j plus k to m, right? And there are a few condition edge cases, right? Say j minus k is anyways less than 0, then we just can't have any number. And say j plus k is greater than or equal to m, that's actually less than 1. And then also, if j plus k is greater than m, then also we can't have any number. So yeah, we'll see that. This just makes us wonder, like, do we really need even this loop, right? We can just say maintain a prefix array. A prefix array will store, say, sum of all dp from 1 to j minus k, right? So say pre of j minus k will store summation dp I minus 1 to j minus k, right? Basically I minus 1 and x. So that's it. The prefix array will just store all summation of all these values, and we'll look into the code to understand it better. So yeah. Before that, we had seen that k was from 0 to m minus 1, right? So one edge case is, what if k is 0? So let's try to build up a solution. How many numbers options are there to place at the first position? There are m options, right? We can place anything from 1 to m. How many options are there to place at the second position? Again m, right? Because say we place an element x, the condition just becomes that a minus b, so if there are two elements a and b, it should be greater than or equal to 0, and that's anyways what a modulo means. So basically each of the m position has n options. So that makes just our answer m raised to power n, right? And this all happens percentage modulo, because this number can be quite big. So that's what I have done. If k equals 0, this is just a basic binary exponentiation code, which I'll show you. So yeah, this is just a basic binary exponentiation code which just computes a to the power b percentage modulo, right? So you can just look up, or if you don't aren't aware of this, you can just look it up on, say, any website like CP algorithms, or just search it on YouTube, right? Now coming to this, yeah. So only thing the change is, again we have just two loops, and the only change is here that we have just computed pre of I prefix array, where pre of I stores summation dp I minus 1 from x goes from 1 to I, right? So simply I've just computed this prefix array, and again a loop from 1 to m. So here just means that the previous element, say the ith element, is fixed to j, right? So I minus element, what can be, right? It can be anything from 1 to j minus k, or anything from j plus k to m, right? So that's what I've done. And the simple, this condition just states that if, say, j minus k is something like minus 3, then this is anyways invalid, right? So we need to just compute when j minus k is greater than or equal to 1, because the previous element's range is also from 1 to m. So that's what I've done. dp of ij is dp of ij plus prefix pre of previous percent mod, where previous is j minus k. So pre prefix array stores is just a summation of dp of I minus 1 comma x, and where x goes from 1 to j minus k, right? And similarly I have computed for other range, which is j plus k to m, and that's it. And this is simply because since I'm subtracting, right, very large numbers, it can go in negative. So just added a mod and again did a mod, right? Because it doesn't, this is just modular arithmetic, If you are not aware of this, you can just search it up on Google. And that's it. We have computed the final answer in the same way. And now the time complexity just improves to O of n into m, right? So we just eliminated the O of m transition time to just O of 1. I hope the solution was clear. Thank you for watching, guys. I'll link the solution code in the video description. Thank you.